All right, folks, this is Mrs. Gifford. I'm back for our second day. So you can just label your paper 6.3 day 2. The second slide here is just the 5 steps of a reminder of how to solve a systems of equations by either adding or subtracting. You don't need to write these down. You did so yesterday. Excuse me, but I just want a quick review. The first one is you're going to set the equations so the like terms are stacked vertically. Step 2, you're going to add or subtract to eliminate one variable. Remember, we're going to add if we see opposites, and we're going to subtract if we see the same term. Step 3, we're going to solve for the remaining variable. Step 4, we're going to substitute that value into another equation and solve. And then step 5, we're going to write our solution as an ordered pair. So let's take a look at some examples, just like we did yesterday. We have x minus y equals 5 and x plus y equals 3. And interesting enough, this equation both has the sames and opposites. Because it has opposites, I'm actually going to choose to add these two equations. As I said, the x's are the same, so we could have subtracted if we wanted, but I'm going to choose to add. And so we have x plus x gives us 2x. The y's cancel, equals 5 plus 3 is 8. And then we're going to divide by 2 to get x equals 4. And now that we have x equals 4, we're going to take that 4 and put it up into one of our two equations. You could pick either. I'm going to pick the first one. So I'm going to take the x out and put 4 in its place. And we need to solve for y. The 4 is positive, so I'm going to subtract 4 from both sides. And I have negative y. This is one thing right here, bringing this negative sign down that some of you are forgetting about. Negative y equals positive 1. And if negative y equals positive 1, then we can divide both sides by negative 1 to get y equals negative 1. And just like we talked about the other day, then we write our solution as a coordinate pair of 4, negative 1. So that's the first example. Let's take a look at a second example. We have x plus 7y equals 16. And we have 3x minus 7y equals 4. Again, always look for either the same term or opposites. And in here we see that we have 7y and negative 7y. Those are opposites. And because they're opposites, we are going to choose to add our two equations together. And again, we choose to add because those 7y's will cancel. X plus 3x equals 4x. The y terms cancel. Equals 16 plus 4 is 20. And we're going to solve for x, so I'm going to divide these both sides by 4, and so we get x equals 5. Okay, just like before, we need to take this 5 and put it in place of x in one of our equations. I'm going to put it in the first one. So we have 5 plus 7y equals 16. And then we need to subtract 5. And we get 7y equals 11. And the last step is to divide by 7. And again, 7 does not go into 11 evenly, so we can write it as a fraction. 7 does go into 11 one time, and we have 4 remaining, and 7 is our denominator. So our final solution is 5, and then 1 and 4 sevenths. If you want, you can change that into a decimal, but you could also leave it as a fraction as I have here. Either is acceptable. So let's take a look at another equation. We have x plus 6y equals 10, and we have x plus 5y equals 9. And as we look at these two equations, we see that each of them have the same term as that x. And because it's the same term, we are going to subtract. Remember, my tip was same and subtract both start with s. And we do x minus x, the x's cancel. We have 6y minus 5y, leaves us with 1y, and 10 minus 9 equals 1. So we have y equals 1. And from here, we take that 1 and put it in place of y. So we have x plus 6 times 1 equals 10. Then we have x plus 6 equals 10. And then to finish solving for x, we're going to subtract 6. So we get x equals 4. Our solution then, again as a coordinate pair, is 4, 1. Again, we subtracted this because the two equations each have the same term. And again, when it's the same, we subtract. So one last example, and then you can get your homework for tonight. We have 2x plus 5y equals 9. And we have 2x plus y equals 13. And again, as we look at it, each equation has a 2x. That's the exact same term. And when we have the same term, we subtract. So 2x minus 2x cancels. 5y minus y is 4y equals 9 minus 13 is negative 4. From here, we're going to divide by 4. So we get y equals negative 1. And again, once we have this negative 1, we're going to take that and substitute it into the equations. I'm going to pick the second equation in this case. I'm going to take the y out and put that negative 1 in its place. And so to get rid of that subtracting 1, we need to add 1 to both sides. And so we get 2x is equal to 14. And to figure out the value of x, we're going to divide by 2. So we get x equals 7. And last but not least, once we have those two values, we are going to write our solution as a coordinate pair of 7, negative 1. So not only do you have examples from yesterday, you have 4 additional examples from today. And then you are going to get a worksheet that continues to work on solving systems of equations by elimination.